Assalamu alaikum dear students. So in this video we are going to solve linear programming problem graphically with the help of GeoGebra. So for this I have a ready mix model in which we have to maximize this objective function 5x1 plus 4x2 subject to all the constraints given here. So let's see how can it be solved with the help of GeoGebra graphically. So first of all, we have to write all the constraints. For convenience sake, I'm taking x1 as x and x2 as y. So first constraint is 6x plus 4y less or equal to 24. So we have this region. Second constraint is x plus 2y is less or equal to 6. And the third constraint is negative x plus y is less or equal to 1. And the fourth constraint is y less or equal to 2. And we have fifth constraint. It actually consists of two constraints, that is x is more than or equal to 0, that is non-negativity constraints. Similarly, y is more than or equal to 0. So we can see this region which actually forms the feasible region polynomial. So in order to get rid of everything else, we have to find the intersection of all these constraints. So this is the common region. So let's try to find the intersection, that is A and B and C, D, E, F. So here we go. So this is the feasible region. You can see this has been highlighted now. And just to again get rid of anything else, let's hide everything else. Okay, now we need equations. We need to plot the equations of associated to all the inequalities so that we can find intersection points of all these equations or the corner points of the feasible region. So for this, let's try to plot the equations. So first equation would be 6x plus 4y equals 24. And the second equation would be x plus 2y is equal to 6. X plus 2y equals to 6. And the third equation is negative x plus y equals 1. And now we have fourth equation, which is y is equal to 2. And then we have x is equal to 0. We have y is equal to 0. So this is how it looks like. Now we have to find all these points of intersection, that is the corner points of feasible region. So for this, we have equation 1, 2, 3, and we have to change the label here. So instead of h, we'll write equation 5 here, equation 5, and instead of p, we have to write equation 6. Now we can find the points of intersection of all these lines. For this, we have to use intersect. Here we go. So first object is our equation 1. So this is the point of intersection of equation 3 and 5. So we have to find the corner points of the feasible region. So equation 3. So the second object is equation 5. So we have this point. Now this point is the intersection of equation 2 and 5. Equation 2, equation 5. So we have this point. Now we have to find this point, and this is equation 1 and 2. So equation 1 and 2. So we have this point, and this point is equation 3 and 4. Equation 3 and equation 4. So this origin is equation 4 and 6. Equation 4, equation 6. Okay, and equation 1 and 6. So we have equation 1 and 6. Okay, and we're done. So the next target is to find the maximum value, find the value of objective function at all these corner points, because we know that the optimal solution lies on the corner points. So let's define this function z. So let z of x y be defined by 5x plus 4y. Okay, now we have to find the value of this function at different points. Okay, point A is 13, value of z at point B is 18, at point C is 21, at point D is 4, and at point E is 0, and at point F is 20. So you can see that the value at C is 21, and that is the highest value of z at all among all the corner points. So this is the solution of this problem. So maximum value of this function is 21 at x1 is equal to 3 and x2 is equal to 1.5. So that's all for today.